Okay, guys, welcome to your first lecture in calculus. We're going to start off talking about limits. And so I'm going to share my screen with you. And let's see if I can get this to work. This is I've tried this a few times now. Okay, so we're going to start off with talking about limits, like I just said. And when we talk about any topic in calculus, we're going to talk about it in a few different ways. One of the ways is graphically, which is what we see here. Graphically, sometimes we'll talk about it numerically when we look at a table of values like this here. And then other times we're going to talk about it algebraically, which means like looking at the functions and manipulating them to see what's going on. So first, we're going to start talking about limits graphically because that's kind of the easiest way to understand what it is. And there's a formal definition of the limit. You're not required to know that for this particular course. It's an optional topic. And so I'm going to focus on kind of the informal idea of what a limit is. If you think about that word, like you've hit your limit, you have this cap, right? You're kind of approaching something. It doesn't necessarily mean that you equal it. It could, but the idea of limit is something that you're approaching in calculus. So here it says the informal definition of a limit. Given the limit as x approaches, let me get my spotlight so you can see where I'm reading. Okay, given the limit as x, notice that there's an arrow there. It does not say x equals c. It says x arrow c. So as x gets close to c, f of x, y, gets close to L. So we read this, the limit as x approaches c of f of x is L. So again, if I'm going to write out what that means, kind of in layman's terms, what that means is as x gets close to c, y gets close to L. Again, it does not have to be equal. So pretend like this value right here is x equals c, which if we went counted by ones, this would be 1, 2, 3. But in general, say this value is c, some x value. What is f of c? Well, f of c means I put c into the function and I look for the output, which is right here, which would be 2. And for this one, the limit as x approaches c, when you see that, you need to make sure that you look at the limit from the left and from the right, both places. So as I get close to c from this side, from the left, and from the right, either way, I approach that value, which is also 2. So in this particular example, you have the limit and the value both being the y value 2. But in this one, say that this was the function f and this is the function g. And here we are at c again. Now, what is g of c? When I go over here and I'm like, what is the value? And I'm like, I don't know, there's a circle. What does that mean? That means there is no value. It actually does not exist. It is not defined for c. But I can talk about its limit because remember, limit has the idea of approaching, not equal to. So what am I approaching? Like, what would you guess the value would be? If you were continuing to draw, you would say like, oh, I'm closing in there. I'm closing in there. And so where am I approaching? I'm approaching this y value of 2 again. So in this case, in example number, so say this is example A, this is example B. In example B, you see we have a limit, but we do not have a value. The function is not continuous, but it does have a limit. So I'm going to clear my screen and I'm going to move down. Let's look at the next part. Again, it says x does not have to, the function does not have to exist there for the limit to exist. Limits do not tell you the value, but it happens as you get close to c, the idea of approaching. Now, a lot of times you'll see some crazy graph, like this graph right here. This graph is a piecewise function. It's made of lots of different pieces, and we want to know about the limits and the values. So this is kind of just testing your knowledge. Do you get the concept? So the limit as x approaches -2. So that means I get close to -2. Here's my -2. I get close to -2. And I find the function's value and I go from both sides of -2 and I see what am I approaching? I'm approaching this right here, which is the value of 3. It's the y value. What is f of -1? I'll do a different color. F of -1 is the value at -1. So I come over to -1, which is right here, and I notice that there's a hole here. That's not the value, but I notice, hey, here's this closed in circle. This is actually the value, and that would be -1, 2, 3, 4, -4. So that's the value. The value is where the dot is, and the limit has to do with approaching. They could be the same thing. Like in this case, they're the same. They're not always the same. This says the limit as x goes to -1. Now that's what am I approaching? What am I getting close to? And I'm getting close to this value, which is at 0, because it's on the x-axis. My next one is the limit as x goes to 3. 1, 2, 3. So here we are. What's my limit? Well, when it's just a line like this, the limit and the value are the same thing. So we're at 2. What is f of 2? F of 2, 1, 2. Let's see. F of 2 is which one? Is it the open circle or the closed circle? Hopefully you said closed. All right, it's down here. The value is -2. And then this says the limit as x approaches 2. Now, again, I said you have to get on the left and right, both sides. So if I come from this side, I'm approaching this value down here, -2. But if I come from this side, I'm approaching +2. So do I put 2 or do I put -2? The question is neither. It does not exist because the limit from the left, the way we write this, the limit as x approaches 2 from the left does not equal the limit as x approaches 2 from the right. And so since they're not the same, the limit does not exist. So this is a practice evaluating function values versus function limits. So now I'm going to clear this, move down. So, and here's another example. This is where it says, again, if the limit from the left doesn't equal the limit from the right, then the limit does not exist. Hold on, mommy's teaching. Okay, use the graph to find the limit if it exists. So let's look at this one. So I have the limit as x goes to -3. Here's -3 right here, the limit. I see these arrows going up, up, up. That means I'm approaching infinity, and I'm going to infinity from both sides. So I can say infinity, or you can say does not exist. Technically, it doesn't approach a number. It keeps getting bigger without bound. The limit as x goes to 2. I find 2. Let's see, where's 2? 1, 2, here I am. And then again, limit has to do with approaching, not equal. So approaching is where we're approaching this open circle, and that is -2. But f of 2 is actually where the closed in circle is. So that is at 1, 2, 3. The limit as x approaches 4 is 1, 2, 3, 4. Here I am at 4. Now notice this one's going down and this one's going up. So we have one going to -infinity and one going to +infinity. So I'm just going to write does not exist. Okay, so that's another example with the infinity included. So now I'm going to clear these drawings and move down. Create a table of values for the function and use the result to find the limit. Okay, so here I have a function. I have this function x squared minus 25, and I have x minus 5. Now, if I were to plug this into y equals, which I'm going to show you in just a second, I put this into y1. And then I try to evaluate it at 5. When I plug in 5, what's going to happen is you're going to be dividing by 0. You're going to have a number over 0, and that means no, it doesn't exist. So you cannot plug in 5, but you know what you can plug in is things that are getting closer and closer and closer to 5 from below or above. And so we're going to do this. Let me move the share screen to this guy. Okay, so we're going to type in y equals, it was x squared minus 25 divided by x minus 5. And then what we're going to do is we're going to turn our table where you can tell it what to do. So you do second and you do window, which is table set. And I'm going to change the independent variable, which is x, to ask. And so then when I come back to the table, it's going to be blank, which means I can plug in things. So I can say 4.9 equals, I can say 4.99. So something getting closer to 5. What if I get even closer to 5? So I can keep typing in numbers closer and closer to 5. Now that's from the left. Now let's check and make sure we're going to the same place if I come from above. So 5.001, 5.01, 5.1. Okay, can you see what's going on here? What number does it look like it should be? Like where if you're squeezing in from the top and from the bottom, it's approaching. This looks like it's getting really close to 10. And this also looks like it's getting really close to 10. So if you had to guess, what value would you guess the limit is? You would guess that limit would be 10. Okay. So I'm going to plug that value in back on our notes. So I don't remember the exact values, but the idea was that this was like 9.9, 9.99, 9.999, and this is like 10.01, you know, like this. So the idea is that what is it approaching? It is approaching 10. So we can say that the limit is approaching 10, and this is called, we're figuring out numerically, okay, with a chart. Now it says create a table of values for the function and use its result to estimate the limit. So now we're going to do the same thing except for this function. So this is what we go put in y1, sine of 1 over x. And this time we're trying to figure out what happens when x gets close to 0. So notice that these values here are to the left of 0, and these values over here are to the right of 0. So I'm going to go back to that screen. Let's change our y value to, okay, so let's go back to y equals, let's clear that out. And we're going to do sine of 1 divided by x. And then we're going to go to our table. And this time we're going to plug in things like -0, -0.01, -0.001, -0.0001. And then if I come from the other side, let's see, 0.001, 0.000, whoops. I should have done that one first, 0.001, 0.01. Okay, what's going on here? Does it look like these are approaching certain value? So we notice some are kind of repeated, so it's symmetric, but are they approaching a value or are they hopping around? Actually, we could look at the graph. Let's look at the graph. You see this right here? Let's see if I can zoom in. Zoom box. Enter. What if it's going to let me do that? Zoom box. I'm trying to get it. So I'm going to zoom in. There's my left corner. I'm going to show you, this would be graphically, but I'm just going to verify what we're seeing on the table. If I zoom in right here, close to 0, what is going on? Do you see that? It is going crazy. What we call that is oscillation. So that limit does not exist because it was jumping all over the place. So we're going to say here, these were all different. And so this one does not exist because it is called it oscillates. Okay, so that's when the limit doesn't exist. It's not approaching to anything that's a clear direction. So let's move down. So these are the reasons why a limit might not exist, which is another thing that you'll see on your homework. So I came up with an acronym actually. Maybe one of my students helped me several years ago to remember this, and we called it JOY. but spelling it with an I. Okay, so J stands for a jump, which would be this one. Okay, so the limit from the left doesn't equal the limit from the right. That's like this situation here. So that would be like a jump in the graph. It's not continuous, all right? Then increases or decreases without bound, that is infinity. And then this one is oscillates. So it's like that picture. Okay, so infinity, technically the limit doesn't exist when it's approaching positive or negative infinity. So again, this stands for jump, oscillates, and infinity. And if you like acronyms to help you remember, like I do, you can remember you have joy, but spelled funny. Okay, so joy, jump, oscillates, infinity. So that's the notes for section 2.2. I want you to attempt to do the assignment on WebAssign. If you get stuck, you can do the Ask My Instructor. You can email me with your Lone Star email. You can post on the homework question board. I also plan on, as time allows, recording myself working out a few of the assignment problems as kind of an assignment help as well. So you have lots of things that you can look to as you continue to teach yourself this course. I hope that if you watch the lecture videos, you give an honest attempt at the assignments, that you will understand the material and will be prepared for the test. This course is going to fly by, and you have to make sure you stay on top of things or you're going to get lost really quickly. So just make sure that you're staying on top of the assignments and watching the video lectures to help. Okay. Good luck. Let me know if you need any help. I'm happy to send you an email or show you a video example. Good luck, guys. Bye.